whenever there is a post for a particular tweet from user A, and the time it will be published for user B, there would be some delay and there is no 100% guaranteed. But if you see, that is what the trade-off we did to have prioritizing availability over consistency. For a particular timeline, if any specific tweet is not exist, that is perfectly fine in comparison for a home page to load all the tweets with 100% guaranteed after querying into this database table. Yes, it will give 100% guaranteed, but if you see, this request would not be able to serve within milliseconds or a seconds, and probably it could take a minute or it could be an hour to query globally into this table to compute the tweet for a user B. So it is not a good user experience, and in fact it is not expected that any homepage would take a minute and hour to load the timelines. So that's why you can understand how and why we are prioritizing consistency over availability for creating the tweets and providing the guarantee confirmation for a user whenever the tweet is being saved into the database. Now, how does these worker would know that this feed which is created by user A that needs to be published on users B timeline? This is how whenever the message is received, this worker can query the relational DB to load the relationship, and it would be pretty fast. So you can think about, or you can again use a Redis cache here to store the relationship. But if you store all the information in the Redis cache for all the relationship, it will not make sense to have another instance of the Redis server. And also we will have a index. Now here in this entity, let's say this is a relational database table, the one we have talked about, right? We can have the index created for the follower ID and the follower ID, so that it would be able to query this database to get the relationship pretty fast. And once it knows that user B is following user A and user A has created the tweet, so this would be added to users B timeline. Now let's talk about the other functionalities of the system, which is like and comments service. So let me have like and comment as one single service, and the database for this would be relational database again. So let me say like and comment database. So whenever user commenting or liking particular tweet, it goes to this service, and this service save this information into the table. And now also whenever these information are available in this timeline, at the same time we have the Twitter ID, and if we wanted to publish like how many like counts and comment counts for particular tweet in the timeline, this worker can query this database as well to know this information. You can also think about using the Redis cache here to most recent information available in this Redis cache, so that this service can query the Redis instance for the latest information instead of querying the database. But this is all depends upon the time, how much time you have. As long as you are able to justify the components what you are using, you are able to talk about that, it should be completely fine. So you may ignore this cache as well. Now let's go back to our core functionalities and let's see, have we missed out any of the core functionality for creating, liking, following and unfollowing users. We are able to cover all the core functionalities into this system. Let's think about some of the areas where we can do some improvements, or generally it can come as a question from an interviewer when a tweet is posted by user, and if Kafka is down and or some messages are missed from this worker, would that be missed forever? So we have talked about real-time feed creation. We can also do the reconciliation process. So in the reconciliation process, it can run hourly or it can run by end of the day. So this process, reconciliation process, let me mention here. So what does this reconciliation process does is it queries, let me make some space here. I am moving this to align with the same process here for reconciliation. Now this reconciliation process can query this DB overnight or weekly and have this timeline created, that is kind of making sure that this information is available when it is missed out by the asynchronous process from Kafka messaging system. So here we have identified one of the use case. It is good if you can identify these use cases, or if it is pinpointed by an interviewer how you handle these. And if you see this reconciliation process, whenever you have the asynchronous real-time processing pre-computation done and you wanted to make sure to have the improvement into the system, you can always use the reconciliation process to run hourly or end of the day to make sure the consistency in the system. Before we complete this deep dive, we have not talked about how this multimedia information will be saved into our system. So as of now, we have considered that this tweet, if it has a multimedia pictures or videos, will saved into this same database as a blob storage. But for making this system scalable, we wanted to store in a specific blob kind of a storage, which is something like S3 bucket. Let me add a component for S3 bucket here. We do not wanted to get involved too much based on the available time for this discussion, because the problem statement for this specific interview could be on how we are loading these timelines and feeds, how the like, unlike, and the follow, unfollow, these relationship works for this system end to end. So let's quickly cover this storage part here. So whenever there is any photos or videos are published, this is generally published directly to S3 bucket. How the client would store directly into the S3 bucket is this service would create the pre-signed URL, and this pre-signed URL client would be able to save this information directly into the S3 bucket. Similarly, it can load directly from the S3 bucket, and this URL will be sent to and fro to this service as a request and response while loading the timeline or creating the tweet. So let me make a arrow here for whenever the tweet happened, it saved the metadata. This service saved the metadata into this tweet DB. At the same time, it creates the pre-signed URL for this S3 bucket and send this pre-signed URL to the client so that they will be able to store the multimedia into this S3 bucket. Further, we can use the CDN link here to have this second level of cache available to the user's nearby location. I've covered the CDN concept on my previous video on Book My Show. Maybe you can watch to get more details for the CDN. So the Twitter service would make this cache available for getting the metadata. Let's check out, have we missed any of the functionalities which we have talked about so far. Now let's check out the non-functional requirement, low latency on the timeline, the cap theorem for viewing, creating the feed. By now it should have been around 45 minutes to 50 minutes for you. We also wanted to cover the operational excellency and engineering excellency for the system. That would be very much similar to my previous Book My Show video, where we talk about the logging, monitoring, and creating the alert into the system. For logging, you may propose using the Splunk. For monitoring and health check, you may propose to periodically check the health of these microservices, and having these information available in the Grafana dashboard, the number of errors occurred within a specific time period. If the threshold is reached, you can create the alerts using the PagerDuty profile, where the developer or the production support team can act upon it to avoid any customer impact. Let's summarize how we started and how we are able to get into this. First is to know the 7-step approach, going through each of these steps, making a note of the functional requirements, and at the same time thinking about the scalability, performance, and quality of the systems, and making a note of it so that when we go into the deep dive, we can actually implement and talk about these functionalities, creating the high level schemas and the core entities, making a note of each of the important attributes that we must need to have the functionalities and data flow working end to end, how we will make these informations available or exposed in a form of endpoints, or rather REST endpoints for our services and systems. Once we gather some of this information, how do we connect the dots between these systems, while high level system design, where we start with something simple and then we get into deep dive, and where we talk about each of these functionalities with respect to read and write path into the system, while creating the read and write paths and different component of the system, we keep back of our mind about the non-functionalities, and where we wanted to prioritize availability over the consistency. And at the end, do not forget to talk about the operational and engineering excellency, which shows your seniority level and the ownership you take while collecting the requirements, implementing it, and taking the responsibilities end to end when the feature goes live into the production. I hope you have learned something today. Please check out my previous video if you have not yet watched, and also please like and subscribe to my channel, which motivates me to create more such videos. Enjoy learning. Thank you. Bye bye.